For example, the suitability of the habitat of Rana japonica is comprehensively evaluated by the basis of the suitability for the breeding season requiring a water source, the suitability for the non-breeding season requiring a forest, and distance between the water source and the forest, and existence of obstacles between the two areas. The table on the left is an SI model that shows the suitability of cover types for the non-breeding season of Rana japonica. The chart on the right is an SI model that shows the relationship between the distance from the water source and the suitability. And the formula at the bottom is an HSI model based on the weight of several essential living conditions. These SI and HSI models must be determined by experts in target species. This is a map that classifies the suitability of the habitat of Rana japonica for the non-breeding season requiring a forest. This is one of the maps that classifies the suitability of the habitat of the species for the breeding season requiring a water source. It assesses the habitat suitability on the basis of the distance from a water source. So these maps are needed as many as the number of the water source. And this map is an overlay of the suitability indices of the breeding season with the suitability indices of the non-breeding season. This Japanese-style HEP can do detailed assessments suitable for a mosaic pattern of land use and habitats unique to Asian countries. For each living condition, determine the SI value for each sub-areas using the corresponding SI model. You calculate the HSI for the sub-areas from its SI values according to the HSI formula. Multiply the HSI by the area of the sub-areas to obtain the HU for the sub-area. These four charts are the final conclusions of this HEP. The upper two charts are for fireflies, and the lower two charts are for frogs. The vertical axis means the total habitat unit, which is the suitability of the habitat, while the horizontal axis means elapsed time. Present means the point of the time before the development project, while future means the point of the time after the development project. All the arrows are downward. It was clearly concluded all the development proposals would significantly damage the habitats of the four species. This state shown by this chart is actually the starting point of compensatory mitigation or biodiversity offset. As the chart indicates, if the development project exploits nature, it will inevitably have a negative environmental impact that cannot be avoided or minimized. We have seen Japan's quantitative assessment effort in EIA. Now this is another effort, simplified quantitative habitat impact assessment conducted by companies on a voluntary basis. In these days, Japanese companies are actively inspecting their corporate activities from the viewpoint of biodiversity conservation. As part of such assessment of their land use in order to make their office and plant sites more biodiversity friendly. The example here is an assessment method jointly developed by Fujitsu FIP, and Mid-Tokyo City University. This is a simplified HEP called Kantan HEP. Kantan means easy or quick. Though simplified as much as possible, it is still based on the basic philosophy of the HEP. As you can see, Kantan HEP assesses not only the habitat within a plant site, but also the habitat within the local ecological corridor. For example, this method assesses how the location of green space within the plant site, which is usually very large, affects the formation of the local ecological corridor. Instead of an HSI model of full-scale HEP, Kantan HEP uses check sheets called HSI chart. As an output of assessment is shown in the form of chart. Everyone can easily understand it. This method directly connects habitat assessment with conservation activities and serves as a tool for biodiversity education for employees. These voluntary cooperative site assessment activities will spread gradually in Japan. Let's move on to the last effort. This is Aichi Prefecture's effort to establish a system for quantitative assessment and compensatory mitigation. As you know, Aichi Prefecture hosted the COP10 meeting of the CBD in 2010, where the participating countries agreed to take effective and urgent action towards halting the loss of the biodiversity by 2020 in the adopted Aichi target. These guidelines will be a concrete method for achieving Aichi target. Aichi Prefectural government first prepared a habitat potential map for 16 typical wildlife species of the Satoyama ecosystem, which is a foundation of Japan's biodiversity. The government then presented a plan of ecological corridors connecting the habitats. These guidelines introduce compensatory mitigation as a mechanism for creating the new ecological corridors. This mechanism quantitatively assesses the habitat loss of development projects that cannot be avoided or minimized, and requires developers to do compensatory mitigation. It can lead to a mitigation banking-like strategic system where compensatory mitigation is provided in a certain ecological corridor. Now let me summarize my presentation. It is necessary to clarify the types and priorities of mitigation measures, avoidance, minimization, and compensation in EIA regulations. Compensatory mitigation, biodiversity offset, and mitigation banking, biodiversity banking, are very effective to integrate ecosystem service value into development projects. For compensatory mitigation, it is necessary to quantitatively assess both impacts of development and the effectiveness of mitigation measures in EIS. Habitat evaluation procedure is a fundamental metrics for such quantitative ecological value assessment. From the viewpoint of wildlife species, it could be modified to suit regional characteristics. It is recommended to introduce simple quantitative assessments such as content for voluntary assessment. This is the full-scale HEP manual I wrote. I heard a translated version of this book will be published in Korea in next year. This is a biotope package I developed in the courtyard of the Yokohama campus of Tokyo City University. You can introduce an ecological corridor accommodating various wildlife species into small urbanized artificial space. This is the end of my presentation. Thank you very much for your kind attention.
Thank you, Professor Akira Tanaka. Do you have any question or comment for Professor Akira Tanaka's presentation? At the complete, okay? Yeah, you.
Thank you for the presentation. I was wondering if the HEP assessment. Oh, sorry. My name is Azusa Oita. I was wondering if I'm a student of the Yokohama National University. I was wondering if the HEP is applicable to the global wide or it's specific for each region.
Yes, it's applicable, but in such a case you have to prepare the local species HSI models for the first time.
So like if we choose different species for each region, then can we connect that?
It depends on your goal of conservation.
That's okay? Yeah. Okay. Thank you, Professor Akira Tanaka. Yeah. The third presenter is Dr. Bolchi Chung. His specialty is ecosystem service evaluation and forestry, and he is particularly participated in the development of the project in MAB in Vietnam. His organization is Vietnam Association for Impact Assessment. Okay, now it's time for you.
Good evening, everybody. And at first, allow me many thanks for about your paying attention on my presentation now. And especially, I many thanks for chairman and the chair board of our workshop here. About my presentation, ecosystem value to local community in Vietnam. As you know, in Vietnam now, like many questions. As you know, in my country, during the wartime, over 30 years, that's why none question on the environmental protection, because the Lord didn't care about the environmental issue. That's why right after the end of the war, my country reconstruction, many big projects. That's why must focus on the environmental question. Yeah. Yeah. first, about the classification of a system in the minor country. For example, you can see on the slide, there are different ecosystem type. Should based on the type of ecosystem should do during we conduct EIA on each project on the field. And very, very important about the classification of ecosystem, because since 1986 up to now, there is a renovation policy in my country. That's why pay attention about this issue, classification ecosystem of investment project for conduct ecosystem system for EIA and C strategy environmental assessment. Very, very important about the classification of ecosystems, not only natural resources, but also so much different natural habitat linked closely with the ecosystem type. Local community mechanism for resurgence, because as you know, during the wartime in my country, the local community role would be neglected. That's why now this question very, very important for EIA and C in my country. There are 9 different types of ecological and geographical regions in my country. In this case, local community mechanism for the resurgence, because there are 54 different ethnic groups in Vietnam, and each ethnic group have famous and typical tradition and indigenous knowledge can use and based on these to apply for EIA and C during conducted investment project in the country. For example, in Sabah, there are 9 different ethnic groups, and the traditional experiences and indigenous knowledge use medicinal plant under the canopy of natural forest to service for ecotourism. That's why the local people can get many high income and for improvement of their livelihood. And other question on the side of Tecmo Power in the Quảng Ninh province by investment from ADB. About this is the composition of mangrove lost for surface to contract and to build the manufacture, but reforestation for mangrove other side by local people. Very successful. That's why they mitigate the compositions of this mangrove lost here by indigenous knowledge of the local ethnic people there. And other some case study Hmong ethnic group, Dao ethnic group, Thai ethnic group, and different traditional experiences and different knowledge to do this one. That's why in here, and up to now, Vietnam is developing the country. That's why there are many big projects. For example, hydropower, Tecmo power, highway, new economic zone, etc. That's why we must prepare the surface of land to build many different projects. That's why link and influence seriously on the local ethnic and local communities. Then in this case, we based on the local communities' tradition and knowledge, indigenous knowledge, to apply it during the conduct the environmental impact assessment and strategy environment assessment to do and very successful in my country. That's why my government now recognize and understand that should apply the local communities benefit for new policy and